ProxOS. Let's get our code editor up. Let's get our file explorer up. Why did I name that Dave? Is great. My name's not Dave. Let's get the manual up. All of the tab types we need, and let's get the runner up. Condition addition. All right. Maybe address 0 contains an integer. Add integers between address 4 and the first many address with an integer value of charge should be added if the value is less than a. Alright, well, I mean, we just set R0 to 4, and then, you know, loop, jump to end if the memory at R0 is 0, otherwise, you know, obviously we could leave real as kind of such socks. Oh! Socks, I thought you left. And also Sojanka, that's Sojanka, you're the creator of the game, right? Howdy. Just playing it on stream. I thought, wow. It's crazy to see people playing me a video game. Wow. Yeah. So I know this is intentionally a bad way of doing it. Ideally, we want to like have it automatically fall through. But you know, we write the loop first. We write and then optimize later, right? You know, premature optimization causes Nooth to break into your room and stab you to death in your sleep. So you don't want Nooth to do that to you. Okay. Anyway, so then we need to check if it's greater than 0. So okay, you know what? No. Let's not. Just be smart about this. Premature optimization is not due to all evil. So at the end of the loop, right, we're going to end up adding 4 to R0, and then we don't jump. You jump unless the memory address to R0 is equal to 0. And then over here, you know, always result into memory address 0. So we're going to have R1 be what we're storing it to, right? And then send it to MX0. And then to exit, right? Finish. Next. So you add R0 to 4. Jump not equal to finish. This is the label. Okay, so loop. So we want to check if the value is less than a. So if the value is greater than a, we don't want to jump. Wait. How's Leopold's code again? Like, am I going based off of... Oh, you have instructions and command and time. Oh, okay. And so instructions, you know, for this, I'm there. Commands, you know, 7 time for even counter. I am finding it back. But, you know, we don't care about time. Oh, my God. There's more people. I'm the last? On time? An addition? How? It's just the one command. But we don't. Let's not focus on previous misgivings. Yeah. So this all. So you know, who cares? We just make a solution and pretend it's on the Pareto curve, and it must be on the Pareto curve because it's the solution that we made. Right. Right. So, you want to jump, if equal to, I mean, we could just do a little bit of a, we could just do a little bit of a, you know, just add a little bit to our one, right? You know, just add a bit, and now we jump if less than. Yeah. No, we jump if we subtract 1. And then we jump if greater than. Wait. Can I just do... No, I can't do that. Okay. Jump if greater than if... This should be mx0. Jump if... Jump to next if mx0 is greater than what we're currently pointing at. Right? No, that's good. If what we're currently looking at is greater than mx0. Yeah. And now he's not, so then if it's not, we add what we're looking at to the R1 register. So that should work, so let's compile it and just do it. So comparing file on line 8 with fams are not correct. So jump if not equal. Integer. We then specify that we want to actually jump to the loop. There you go. Compile. And would you look at that, Bob's your uncle. Got that programming right here. So let's look at the leaderboard and see how obviously everyone must be worse than us. Honestly, instructions, that's not bad. Don't know how people did. I mean, okay, so obviously they saved one instruction. Wait, instructions. Wait, what? Oh, instructions total? So it's instructions multiplied by... Wait, now I don't get... Instructions, commands. Oh, wait. Oh yeah, commands, instructions, how many... Is this time just a factor of instructions? It doesn't seem like it. I wonder how time is counted. Oh. So we have... So people got one better command over us. And I don't know how. Is it because... They managed to... What happens if we just don't have this? We need sub afterwards, though. That's the issue. They coded it. We can't store it in MXCO. Oh, wait, no. Doing it the wrong way. We sub it... We put the result of this into into R1, right? So we don't need to compare it to MXR0, we compare it to MXR1. And then you can add to MX0. Right? Yeah. And then we don't even need to move here, but we do need a we do need to move 0 into mx0. I don't think we saved the command here. Okay, compile this. Okay, so now it's wrong. He just made everything worse. Well, that's gonna happen if you do things in the wrong order. Now it's never correct. Wait, this seems to be MXR0, and this is R1. Okay, so now it's working again. But now this seems like it's going to be more amenable to cutting out a line. I'm on the corner, I'm catching a line. You don't need this here. You don't need to do it here because we're setting it to 0. So, and we don't only check here. So actually, this works. Pile 1. Okay. I think we got into the highest commands. Condition. Yep. Better than statement. Take that. At least for this specific one. Very nice. Yeah, I think it's nice too. Okay, fine. We need to save this. Make a new file explorer. Make a new file. We're gonna call this conditioned addition. What? With hell? Oh, yep, you're the creator of the game, right? I'm calling you, right? I found a bug. Because I already made one called Condition Edition. So it doesn't, yeah, it doesn't like it when you try to create one of the same name. Now if I delete that, I'm ready to send to you. Okay, I'm gonna delete both of these. Make a new file called Condition Edition. Condition. Okay, now that works. And now you want to save this. Do Condition Edition as commands min. Alright. I guess it could just be commands. Just call it commands. And then delete commands min. Anyway. New one. Let's go for rhymes. I think it's natural, you know, it's fun to go for, before you optimize for speed, just optimize for code compactness. Because then you can, usually code compactness very naturally expands into speed. Right, which is some simple tracks with like loop unrolling and whatnot. This is bad. This game makes me want to have coffee at 7 p.m. Right, because it's just so nice for it, and then you stay up all night. Determine if the integer located in memory as 0 is prime. Okay, run into memory as for f prime, otherwise it's 0. Alright, well, simple prime checker You just test if it mod anything is 0. Right? Yeah. So some frame checker is, the idea is from 2 to n, fn, like I from 2 to n, fn mod I equals 0, return false, otherwise return true. Right? And this is minimum circuits because obviously we're doing a lot of computations. Because we only need to check prime numbers. We don't need to check above root n, right? We don't have to. We don't have to check. You don't have to check primes. We only need to check primes less than root n. But this checks like every number. But that's fine. So we're going to, so first things first, we're going to need to get the index. So we're going to move, we're going to subtract 1 from at max memory 0. This is wrong. It's n minus 1. We want to take the mod, put into R1 of mx0 mod that. We want to put in a 1 into index memory 4. And that's going to be a special trick that we're going to use later. Which is right now. And we want to take the maximum, the minimum of mx4 and R1. Right? So if this ever is 0, it sets mx4 to 0. Otherwise, it's going to set to 1. And then into sub 1 from R0, and then jump if it's not equal to 2. And we're going to jump it into the loop. This needs to be mod with R0. You're going to go into the loop. And then if it's not doing that, we're guaranteed to have the right answer into R0. So compile it, run it. Nope, my computer did not like that. We got a crash, everyone! That's fun. Wow. I hope it saved my work. Oh, no. Oh, I didn't. Okay, that's what you have VODs for. Who needs saving when you could just live stream and then watch the VOD afterwards? Alright. Hey, that's the wrong VOD. There you go. Here's fake VOD. Okay. So here's what we had before. And I think that you want to get a file explorer. We want to get a runner. It's called Fimes. So let's make a file called Fimes. Move into Fimes. We want to save this into Fimes as first try. And we want to go from I from 2 to n minus 1, f n mod I equals 0, return false, otherwise return true. That's what we're doing. mx4 1 subby r0 mx0 1 loop modi r1 mx0 1 min e mx4 r1 subby r0 1 jump equal to I loop r0 and 2 should be 1 actually, and then we want to exit. We want to save this before the game crashes again. There you go. Alright, so why would this crash? Also, I want manual up. I just like having up here. Okay. Yeah, you're jumping not equal to. We're taking the modulus. We're not messing. Did I actually get like a Y0? Well, no. This should be R0. Save this. Compile this, run it. Compile it. Line 4, command amateur, incorrect. MX4. Compile it, run it. It gets some commands correct. It gets some correct. It just likes crashing. It likes crashing quite a bit. Let me look on the Discord. Doxing myself with my computer specs. Do we have to get like some sort of Code where? What's the purpose of this code viewer? Like, oh wow, it's viewing code. Yay. Primes. Going to open up primes. First try. This is wrong. We're going to make a dummy display thing. Debug. Manual. Go down here. Sync is called. That's what it's called. Alright. So I know it's crashing on the fourth one. Let's say this. So play. So let's go into the register view. The memory view. These are integers. So we want to see if 5 is prime, right? So we put 1 into the output. I guess actually it's fine to stop there, but why not? Whatever. We put 1 into the output. We subtract 1 from the output and then put into our first register. Uh, 5 mod 4. Wait. Which way does mod go? which way does mod go? Should be the other way, I think. R0 MX0. Okay, stop. Save. Compile. Run. Second input. 37 set input. Oh. Okay, so 2. Ha. Okay. So it's going down negative infinitely forever. Which seems bad. So what we do is we don't do not equal, we do jump if less than. I have comparison operators that aren't jump commands. I'm too used to Saxophonics games. This is a luxury that I don't typically have. Couple times, you know I cannot lie. Yeah. Jump if less than 2. No, jump is greater than 1. Or 0 is greater than 1, jump back. Okay. Okay, well, it's not working on all test cases, but stopped crashing the game. So that's an improvement. Let's see here. 1, 2, 1, 2, 3, 4, 5, 6, 7. 52. I think it's the other amount. I think I got it first time. Really? You have the special case 1? Okay. I feel like we could do this cleverly, but F mx0 just dump to E. F mx0 is equal to 1, okay? Don't want. Does this work? Okay, primes are complete. But obviously that's gonna hurt. Yeah, what? The score. The score is. Oh, we could take this. We could tie the global commands if we just learn how to pack it better. Do we want to do that? I kind of do, because we already have this whole cool thing. Okay. Let's say that's first fine. Make a new code. Let's view the previous code. So you want to find some way of like connecting the hack. Ah! I'll do I'm smarter someday. Let's go straight to this one. Starting. Sort out inches between the add 0 and the first memory has an integer value of 0. So the inches in the setting 0. Right? The starting inches in the same memory range. Okay. Sure, so, we're gonna go with insertion sort. Cause that's easy. So, I'm going to have R0 be sorted. We're gonna have, R1 to be R0 is going to be the one to swap. So, I need to swap something to always be at memory as 0, right? Yeah. Is it? And R1 is going to be the sub range. So, oh, it's going to be head. So, first we're going to set R1 to R0 plus 1. And then if compare, so if R1 is less than R0, going to go to swap. Well, first I can check that R1 is in bounds. So if R1 is not in bounds, I think to compare what's it at R1 to 0 is not, we're going to go to next meme. Otherwise, we're going to jump if less than 0. And so we know that's not pointing it at 0, and we know it's not pointing at that. So we're going to add 1 to our 0. Just do it first. R0 is greater than R1. Go to compare. Movie R1, R0. We're going to add 1 to R0. Start. And if then comparing, yeah, we want to compare the memory address. These are integers. These are integers. You do 4. And then FV, as long as we're not looking at a 0, we can continue. Otherwise, we've done. And swap. Still like easy swap thing, right? Yeah. So move. Oh yeah, we could do in 2 ones because we have addition. So I'm going to add R0 to being what's pointing at by at R0 to mix R1. This just gets away with us not having to use another memory address, but we don't care because we have infinite registers. Okay. So move to R3. What's pointing out by R1. Move MXR0 to MXR1. Move MXR0 MXR0 to R3. And we want to jump to start. Don't like this jump start here, but anyway. I think that's cool. I think that's chill. I think that's good. Compile. Let's get the register view and memory view out. Got this one pause. So we're at 0. For as an R1. 16 is not equal to 0, so we don't jump. We're comparing if 16 is, if 13 is greater than 16, it's not, so you go back to compare. No one stop. Jump if greater than. If P2 is greater than P3, moves P1 to C. That's odd. So MXR0 we want this to be less than actually. Wait, no. The default needs to be that it jumps. We do have the saves, right? We do not have the saves. File Explorer. It's going to be our sorting. I'm going to save this into sorting. As first try. If the memory R0 is greater than memory R1, which is not. No. You know what? Less than. Yeah. Yeah. Save. Stop. Compile. Don't even bother. Just fucking go for it. Pog. So leaderboard, sorting, commands, local. Oh my god, we're so close. We're so close. I can smell the wasted. I can't find it. Just save it. Go to the next one. Group union. Memory edits 0 and 4. We should save it, right? Yeah. And we're going to need to get a new called group union. Memory is 0 and 4 contains 2 inches. After that, you have group A inches or group B inches. Return all inches which contain both groups. Okay. I mean, that's in the first occurrence in group B. Is there some nonsense where it doesn't want us to... The output must not contain duplicated images. Okay, so say the integer we want Next meme, right? And then we have this add it to a end, right? And even save and save often. Group union. First try. I'm gonna go use the restroom for a bit. Be right back. And I'm back. Anyway, so right at the end. So what are the points going to be? I'm feeling like R3 is going to contain start of point to start of end list. You can say that R4 contains number to be added to end. So, I mean, that'd be like mx0 plus mx1 plus 2. Actually, I'm going to add 2 to mx1. To mx0, I mean. So now we don't need to add 2 here. swap pointing to B. Yeah, swap pointing to B. We might point to sort of endless is here. Actually, you can do MX1, MX2. These are integers actually, so you want to have 8. A start is 8. B start is 0. C start is MX1. 4. So, can have R1 as a head, right? R0 as a head, I mean. We can have R3 as an end head. So, let's see here. You want to add MX0, no, MX1, MX2, and blah, 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 blah. I'm going to move MX4 to R3. And goo. So if we first here we check jump is not equal to 0. And if it is equal to 0, then we want to move what's pointing to our x into into R0 into what we're looking at. And then if what we're looking at is equal to looking at is equal to 1, no, it's equal to returning to part n. Go back to the next screen. Otherwise, you add 4 to R3. And jump back to number to the end if it's not a duplicate. So you want to start head at a B start. So we want to move MX0 into B start. Is A head. Yeah. So you actually want to move MX4 into that. Save and save often. Alright. And then A head. We want to move B head. Okay, yeah, this makes much sense. But sure. Move A start, which is 8, into the A head. And loop. Where if we test if what we're looking at with R1 or 0 is the same as what we're looking at R1, then we want to add it to the end. Otherwise, we're going to add 4 to our A head. If it's not equal to our B head start, which is at MX0, then you want to go back to loop. In this case, it is equal to B head 0. So you want to add 4 to B head. And jump to next meme. And this should actually be dance because you want to add stuff. All of this can clearly be done much better, but I think it's fine. Let's put a stop here. Let's compile this. Line 9 is wrong. Movies. You gotta remember movies. Jump doesn't take any parameters, but okay. Save and save often. Compile it. 1. Don't need this. We don't need this. Debug. Distribute. Thank you. All right. Yeah, it's human fork name. $13? What? What? Groove A inches followed by groove B inches. This is test case 1, right? Okay, good. Test case 1. Test case 2. I said 13 and 18. What? Oh, because I already converted to pointers. You dummy. Alright, and I also learned that we need to multiply them by 4 too. I think R0 might be running forever, guys. Yeah. Jump not equal to next meme, as long as R0 does not equal to C start. And if it does, then we can exit. Make sure to compile it. I always compile and doing code changes. Unless I forget. Which I never do. Check it out. It's being dumb. It'll do next year, right? Yeah. You know, what if you just full send it, right? If you full send it, it gets permanently stuck. These should be ends. And we exit out of bounds, you know? We're getting the real errors here. Now there's infinite loop nonsense that crashed my computer, that crashed the game last time. We're getting the primo errors. As long as it's less than. Hey, look at that. We sometimes get positive, good results. That's a Jask promise. Sometimes getting good results. Can we size this? You're lying. Bottom right corner. You're shitting me. You can resize this? Oh my lord, look at this. Finally, we can truly game. Now I can know what we can do, what all these commands do. Yes. Bitwise OR. Mmm, tasty. Yum, yum. Okay, well, now we can just, or we can make it super tiny, right? You can go like, dun, dun, na 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 na. Ooh, that's janky. Now, 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 now. This one go any smaller than this? Come on. Now that's what we call gaming. Anyway, okay. Let's make sure it's actually being correct about this memory pointing stuff. So, go back to here. Compile, run. So they're saying at memory point 28 is when the first list ends. Okay, actually, let's start right here. So we have 5 and 5, right? So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So I would say that memory address, so 16, 0, 4, 8, 12. 16. You switch to bytes per row 4 to make it easier to view integers. That's fair. That's fair. Yeah, okay. Yeah, so we have 5. So 1, 2, 3, 4, 5. So 24 is what should be, or or B start. Right? No, 28. And then 1, 2, 3, 4, 5, 48. So you should be seeing 28 and 48. And that's exactly what we see. Well, glad that part's working correctly. So now we move C start into R0. That's wrong. We should be moving B start into R0. It doesn't work now? Hell yeah. Alright, there's a lot of optimizations you can make on this. Let's look at the leaderboard though. Sorting. Oh my god. Oh my god. Okay, we gotta win this. We gotta win this. Let's see, what's the biggest? I have ideas. Profane ideas on how we might be saying. Oh, do we have like longs here? Is ints the biggest things we can have? Yeah, 32 bits. So you can't just like do the multi directly into this. Okay, let's think about when we use these. So do we use MX4? When do we use MX0? You use MX0 right here. And nowhere else. No, tell a lie. We use it here too. Okay. So we do use it. We do use it. Let's see here. When do we use A start? We use A start a lot. When do we use C start? MX4. Right here. Just right here. Then we don't need this. X4 divided by 4. So this can be can save this by making this multi MX4 by 4. Save this. Compile, run. Undo what I just did. Stop, compile, run. Okay. Save this. Copy it. Make a new one. Before you start fucking anything up. Okay. Right. So, MX4 gets used here. It gets used for the next meme, too. And it gets used here. MX0 gets used here. How can you squeeze the 3 commands? I could do the looping and it's co-flow and not a dumb way. That's an obvious way to do it, of making it better. No, you what? Hey, we lost the top 3. Okay, there you go. But it doesn't want to scroll now. Huh. Okay. Huh. I mean, I forgot, is it little Indian or big Indian? Because I think we could do some evil bet hacking here. Take a look at this. Maximum for an unsigned byte is 255. So do we ever go more than 255 here? Let's see here. We do not go more than 255. It's based on your system. Times 86. What do you mean it's based on my system? You're telling me that in this game, it might make a different sense if I switch to a computer using ARM? That potentially someone can make a solution. Does ARM use Big Endian? I forget. But someone can change your processor architecture to have a solution that works on. What? Are you serious? What? It's based on your system times 8? Really? I think... I think you might want to change... Maybe do like the leaderboards based on architecture then. If, like... Because for bet hacking, like Little Endian and Big Endian can make a big difference. Right? Like, it could save a few commands. You know? Like, the whole point of like games over like using like programming challenges, right? Like the whole interface is so that it's portable, so that we can all have like the same, in terms of like a leaderboard, and have the same challenge. Basing on architecture is crazy. I'm sorry. That's hilarious. That's insane. Again, it might make more sense on your end to do it that way, but that's crazy. That's crazy. Alright, anyway. Yeah, so they don't go over 255. We can just... I forget. byte. And we can do evil x1. These could be unsigned bytes. And now we can just do multiply integer mx0 times 4 here. And then right here, mx0 should be byte, should be unsigned byte. That's fine. That's fine. That's fine. I think, yeah, as long as we, yeah, every time we reference mx0, it should be as an unsigned byte, which it looks to be. All right. So doing that, save the command. This evil bit hacking. Yeah. Well, it's not bit hacking. It's making assumptions on the inputs. Because none of the test cases ever use a pointer that's greater than 255. And that squeezed out. I was looking at the wrong thing. Okay. Really? Only 4 people tried group union? Huh. Well, I mean, obviously, this is really bad if Alien got a 13. It is so bad. It is so bad. This control flow is spaghetti. And let's just save it and continue on. Group union. Commands. Alright. Fibonacci puzzle. Tell me no one has done Fibonacci before? Alright, it's because I haven't done it yet. It's probably because I haven't done it yet. Here we S is 0 and 4 contain 2 integers. Calculate the sum of all Fibonacci numbers. And this is between A and B inclusive. Fibonacci number. Alright. Sum of Fibonacci number formula. Okay. Sum is f of n plus 2 minus 1. So answer is f of a plus 2, f of b plus 2 minus f of a plus 2. Looks to be. Let's see here. Now, if you have enough memory, I think so. Probably. I hope so. Let's get some dummy sync commands here. And go to here. Three and 5. 3 and 3. Sure, we could just do this. 3 and 5. 3 and 3. 3 and 6. 6. Yeah, the way I'm doing it, it just can't be. See if they want us to do ones. Seems like the minimum one is always 3. I think so. So if that's the case, then we need the 0. 0. So we have something like this where it's 0, and we just have like nonsense 0, nonsense 1, 2, and then at 3 is when we actually have f of 5. Yeah. And then 4 equals, it's a Fibonacci number. F of 6 equals 8. And that's going to how it's going to be looked at like in memory. So then we have f of 7. So you want to move I do kind of want to pack it. Yeah. This thing save us some time in the long run. They do get better than that. No, let's not pack it. Let's not pack it. 4, 2 times 4. So you need to multiply x0 by 4. Gotta multiply mx1, x4 by 4. You need to move this is times 4. So 8, and memory location 8. We need 5. Oh no. No. Memory location 12, we need 5. And then at memory location 16, we need 8. And then we need to move You think we need more than 64 numbers? Yes, we do. It's 232. But that's just a that's just a short array. Move short into MX8, and you want to move in it's going to be last, so it's going to be at 12, unsigned short. I can move unsigned short MX10 as 16. No, it needs to be signed. It needs to be signed because these are assigned inches. Right? No, it doesn't. What's the difference between signed and unsigned integer? Absolutely nothing. Say it again. Because it's never going to be negative. So the first bit is never going to be flipped. So we are chilling like a villain. It doesn't matter, actually. It really doesn't. Yes, it does. It does matter. It has to be unsigned. These have to be unsigned because the nasty bed chef left nonsense we're going to be doing relies on it being signed. No. Wait, are you in bed chef left? Wait, that's not. Wait, what am I doing? What am I doing here? We don't need to be doing any of this nonsense. Yeah, okay. No, don't do any of this nonsense. Move 16 to R0. And move 12 to R1. And then, let's see here. Ba, 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 ba. We are the crystal gems who always save the day. Move I0 to 12. And so loop. We're going to move R0 into R1. We're going to make R0 R1 plus 4. Set 4 to it, honestly. And then no, you need 3 of them. You need 3 of them because we need past, present, and future. Yes. Yes, 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 yes. So we do need to do the evil nonsense bit hacking. I don't. You really don't. You really don't. You could, no, we do. Do we? Troubled times, and you know I cannot lie. Move 16 to R0. Right? And then we're going to move R1 to R. Subby. R2 into R2, R1 by 4. And then movie. Add the 4 to R0. And then add the into what's being R0, MX R1 and MX R2. Formula, it's just a straight formula. Formula for term and Fibonacci sequence. It means phi divided by square root. Okay, you know, I have an idea. I have an idea. I have an idea. I have an idea. We just hard code it. We hard code it. We make a fucking lookup table. Using a program counter. They'll never expect that. They'll never see it coming. Okay. Like, hear me out here. Hear me out here. I'm pulling up Visual Studio Code right now. This is programming. Okay. Alright, new file. New Python file. Alright. See here, did we switch over to this? Yes, we did. How do you zoom in for you guys? There you go. That's too close. There you go. Alright. So I'm thinking of something like, sub this out first. Alright, and you save it. Elite hacks. Alright. So, you don't need this. So, it's a Fibonacci, like, module on Fibonacci, Python package. So let's do for I first equals febs equals 0, 1. Range, just go like 200 because I think there's only 200 of them. Fibs dot 0, and then we print fibs. Fibs append fibs -1 plus fibs 2. Alright, lead tax, and so we run this, and then we get, you know, it's the Fibonacci number. It's your favorite. Look at them. They're forming like these weird fractal things in terminal. Yeah, so we can, you know, anyone can print out 200 Fibonacci numbers. But, so now you have the Fibonacci numbers. So, for fib and range, they have a output equals this. My genius. It surprises even myself. For I n verbs right, so we can do this, and we can say print I, right? And so now, you know, we don't start with we only start with 2. Right? We only start with the third Fibonacci number. Third? Yeah, third. Which is good, because the lowest one we have is 2. So, you want to print out. You see where I'm going with this? You see where I'm going with this? Jump to next. Look at that. Right? So now this is code. So we know we don't actually need this because it goes up to far beyond like what we can actually handle with the this. What's the maximum int they have? We know empirically it doesn't go over like 150, right? So you can just take this, you know, reasonable amount of code. Close down this. Does that work if I close down? Yeah, okay. And I go over here. Save this as you actually need to create the file. Oh. Fibonacci. Now go to Fibonacci. Save this as not late enough. So we have next. Oh, okay. So you can't actually go over here. You could do the alternate cheat solution, but nah. I like using our program counters for malicious malfeasance. We have one space. We have one space. Oh yeah, baby. How much space do we get? Oh man. Oh man. You're too generous. 384? Alright. Alright. pretty sure 136 is the maximum we end up using. We actually want to jump to MX1. And for I and fibs 3 plus. We actually want 4 plus because we know the minimum is 3. Now, nothing about this is super specific on it. We're just storing our data in an unconventional place. That being the program pointer. Where does it want to go again? Let's see here. That's the leaderboard. Fibonacci puzzle. Memory address 8. Okay. Add to memory address 8. What's an R0? And I. You actually want subby. So, does this fit? This should actually be exit. Let's go to forward to 100. This one. And you know I cannot lie. I'm off the wagon and I'm hitching the ride. Okay. I mean, let's Fibonacci hacks. Yeah, let's make a new one. Desync. Pause on that. What is our biggest numbers and smallest numbers? So you have a 1. Okay. So you do have to include... Can't skip anything. Well, we can skip the first 2. Yeah. Let's think about this way. A min equals 1, A max equals B min equals 5. minus 3. One, 6. 1, 4. 5. 2 and 7. 6, 3 and 9. 3 and 10. 7, 3 and 8. 4 and 9. 3 and 36 and 132. Yep. So that's the biggest one. So we need to get up to 36 and 132. Luckily, we have some elite hacks. So the assumptions you're making. You're not hard coding any testing inputs, right? You're not. And so if you look onto Wikipedia, sum is f of n plus 2 minus 1. But we start with the first one, so it's only you want to go with 1. No, that's for future. We don't want. It could be is at 1, which means 0. So the sum, quote unquote, is 1. Minus 1, but then cancel. And then, so the maximum is 36. So we go up to 38. The maximum for this is, the minimum for this is 3. So we only need 5. Well, technically 4. Max is 132. Actually, no, it's right. It's 37, and then 32. So now, if you want this, this can easily fit within our terminal. 328. So how much room do I have? We got plenty of space. Wait, what? Wait, what? Huh. Wait, no. Okay, it goes up to 394. So we have some space. We have space. So now this is a bit tricky. So you want to multiply mx1 by some number n, and you want to add some b to it. You want to multiply mx not mx1, mx0. mx4 by some n. You want to add you want to multiply it by 2 specifically. You want to multiply both these ones by 2. You want to add some, and you want to add some b to it too. Yeah. And then we want to jump. Oh, goodness gracious me. That should have been mx4. All right. And then we want to jump to mx0. Yeah. So you want, if mx0 is a 1, you want to correspond to this. So the corrective factor is 4, because we want to get 6. So test case 1. Let's view memory view. Wait, no. Compile. It doesn't like that. Let's just say 100 for now. Actually, no. So we are assuming the minimum for 4 is 3. So you add 70 to it. All right, stop compile. Line 162, really? Really? Huh. Fibonacci hacks. But open up, not enough. Heck's still fine. And review. 724. I think we assume too large. Let's do, yeah. Let's do max 1, min 1, max A6. For both of them. And then, because I think I got myself confused there. It still has to be 4. And you see the first exit right here. So still at 76. So now it needs to do 74. Yeah. Alright. Say that's hex. Oh no. Fibonacci puzzle. Compile. Oh, stop. Compile. 1. And 5. Compile. Goes immediately 7. Okay, does it need to be off by 1? Oh my god. Oh my god. Haha. Oh, shit. Okay, so our assumptions are that's going to be less than 36. One 5, yeah. 1 3, yeah. Actually, have line. Just get self. Really? Should we go to 7? 2 7. Let me go to the 87th. What's the 86 really? 8th? Made 19. Is 7th Fibonacci number? Eight. It's 2 more than that. Yeah. So it's 21. I think, yeah. So it wants to count the edges, right? Which you're not doing right now. So it's only working, it's working with 1 right now because the edge of P would be 0. So the difference between not counting it quote unquote properly would be 0. But it's not working, it's not 1. So what we need to do is we have the long offset for here. This needs to be from 1 to 37, I believe. Yeah, let's actually put this in code, where multiply mx0 by 2, add the mx0 by, I'm just thinking way out anyway. So now swaps at 78 instead of 76. So you need to add 2 to this, I believe. And this needs to only be added by 1. No, keeps where it is. I think. I actually went the opposite way. Oopsies. Okay, well, we could just do 7. 3, and we want to take that here. Right, and so actually this should be 5. Oh, it shouldn't. I have it first time. Delightfully devilish, Seymour. Oh shit, I had it covered. I modified this. Anyway, what a great solution. Well, I like to only do these streams for an hour, and it's been 2 hours and almost a half. So I'm gonna call it now here for ProxOS. Come view next time when we do, I don't know what, occupied slots, most common game life, and Simple Maze. Fare thee well.